Alright everybody, welcome to lesson 5. We're going to look at solving some of those quadratic equations by something we've actually already talked about, but by using factoring. So this will be a nice review of all the factoring stuff that we've done, and we'll take it one step further and to see how we can solve some of those equations. So, okay, this works good. Okay, so at the top, there's some of the recall stuff which we've talked about. So again, remember when we're factoring, we have to determine two integers that will multiply to the last term and add to the sum of the middle coefficient. So there's the rule here which you can read, what we've done before. So we'll factor these two trinomials here. So with A, we're trying to find two numbers that are going to multiply to give us 4, because there's a 1 in front of our x squared, so we're multiplying those together, and we want to add up to our middle one, which is a -5. So the two numbers that make that possible are a 4 and a 1 in some combination. I think that should work. Yeah, 4 multiplies with 1 for 4, but if it has to add to a -5, then that means both of these would have to be negative to make it work out. So our factored form is going to be x minus 4, x minus 1. So we can factor it quite nicely. But for B, the numbers are a little bigger, and it's helpful that each of them actually has a common factor of 5, so we can remove that first as a greatest common factor. So x squared plus 8x plus 12 is what we're left with. So we're going to do the same process and find two things that multiply to 12 now. And the same two numbers have to also add to 8, and it looks like 6 and 2 will be the ones that make it possible. So our factored polynomial then, 5 multiplied with x plus 6, and then multiplied with x plus 2. So we can factor all of these things using the rules we did before, but now we've got to factor them in order to solve something. In the last video we saw that if I had equations that were equal to 0, I was looking for a 0, in other words, an x-intercept. And we saw how we could do that using our calculators, but now we're going to do this using factoring. So we can do all of this by hand, and we can plug them back into verifying checks. So we'll do a couple. I won't do them all in here. That way you can have some which you can try out and check the answer key out. But with the first one there for A, let's determine what the factors are first. So if I can factor it, that's great. So we're going to find two numbers that multiply to positive 12, but also add to 8. So 6 and 2 again seem like good numbers, but both of them again need to be negative for this to work. So our factored polynomial is going to be x minus 6, x minus 2 is equal to 0, because I still have that attached, so I just got to bring it down with us. But now what we're able to do with factoring is, well, if one of those sets of brackets is 0, and I multiply that 0 by something, the whole left side of this equation becomes 0. So I'm looking for the two values of x that will actually make this true. So on one hand, if the first set of brackets is 0, then I'm good, and it's a true statement. But also on the other hand, if the second set of brackets becomes 0, this is still true. So I need to solve these two little equations. So I know that x could either be 6 or x could be 2. And we can check these, we can verify this quite easily by substituting back into our equation. So if x is equal to 6, well, that means that it's 6 squared minus 8 multiplied by 6 plus 12. So 36 minus 48 plus 12 will give us 0. So I know it does work. And I checked the other one also. So if x is 2, well, 2 squared minus 8 multiplied with 2 plus 12, well, that's 4 minus 16 plus 12, which again will give me 0. So I know that both of them do work. And I do need both zeros here, because if I were to graph this, I'm going to have two x-intercepts. And you can see each of them, we found them, right? Like x is 6 or x is 2, like those are my two. So we can do a couple others, but they all work essentially the exact same way. So we'll do one more of this type, and then actually maybe we'll do a couple this type. So we'll do these two here. We'll do B and D. and then I'll leave the rest. I'll have the answer key before you so you can check to see how they went. So for B, again, you're looking for two numbers, multiply to negative 20, this time add to negative 1. 4 and 5, I believe, will do this as long as it is the 5 that's the negative. So x minus 5, x plus 4 equals to 0. So that means x minus 5 should be 0. So x is 5. There's 1. X plus 4 equals 0. So x has to be negative 4. There is the other. So I found my two zeros. Right? They're always the opposite value of your factors. Right? The two numbers we had were 4 and negative 5. My zeros are 5 and negative 4. They just switch place. Well, the negative switches places in this case. Right? They change sign. So if we do D as well, well, there's only two terms in there, but they have a common factor of 2x. And this is, well, remaining is x plus 5. So again, it's still factored. So I know that 2x is one of my factors. I'll make that equal to 0. So I know that one x-intercept is 0. Or the other one, x plus 5, is 0. So I know that 0 is negative 5. Right, and again, you can graph it. And I can show you what it looks like this time. So if we clear out all the stuff from last video, 2x squared plus 10x, and we'll graph this. Okay, so I see one of them goes through 0, the other one goes through negative 5, and I can find it again by doing second trace 0. As long as my cursor is moved into the right position, so the left side of that intercept, enter, the right side of that intercept, enter again. There it is, negative 5, just like we said it would be, right? And the other one I can see goes through the origin, so I've got my two. But sometimes, I'm not able to factor this as nicely because I have to use that longer method of decomposition. So we'll do, a couple. These ones are already solved for us, so we won't do these ones. These are just the examples to look at. So we'll do, A and B here, and then we can talk about a difference of squares, that last type. But really, all the factoring rules that we've seen before haven't changed. So let's talk about, oops, where did this go? Sorry. Let's talk about A here. Now the only difference is really we take the number in front of our squared term and our constant, and we multiply those together. So I want to multiply to the product of 2 and negative 5. So really I want to multiply to negative 10, but I still want to add to the number in the middle of negative 9. So it seems like 10 and 1 is a good combination. Negative 10 and positive 1 will do this for me. And again, for decomposition, to remember how that worked, it was the middle term that gets, decomposed into two terms. And the reason why I know it's a negative 10x and a positive 1x is because of the numbers that we found before, right? That's how we split them up. And once we do that, we group them into two groups of 2. So 2x squared minus 10x plus x minus 5. And again, in the first set of brackets, there's a 2x that's common. So I'm left with x plus 5 inside. And am I left with x plus? No, it's x minus 5. I wrote the sign wrong. There we go. And there's my x minus 5. And now I see that my brackets are the same, so that the brackets become one factor. And the other factor becomes the coefficients of them. And I've circled in red the second set of brackets because really there's a 1 in front of it. Right? Really there's an imaginary 1 there. So I've got my two factors. Oops. So this is still equal to 0. So now the rules are the same. Take each factor you found, make it equal to 0, and solve for x. So one of my x-intercepts here is 5, but the other one actually ends up being a fraction. So if I subtract a 1 from both sides, it's negative 1. So I know that here x is actually negative 1/2. So I've got my two x-intercepts, but with decomposition you're going to find that one of them, more often than not, is a fraction, which again is okay. We can do this for B as well, so we'll do this one more time. So there's no common factors between 3, 8, and 5, so I have to do decomposition here. So we'll take 3 and 5, we'll multiply them together, so two numbers have to multiply to 15, but they will add up to the number in the middle, which is negative 8. So 5 and 3, when they're both negative, will make this work for us. So 3x squared minus 5x minus 3x makes up our negative 8x's, plus 5 is the constant on the end. So when I group them this time, there's a subtraction sign to be aware of, and if I break it off my set of brackets, my signs inside that second set of brackets change. And now it looks like it's going to work out because both the brackets have a negative sign. So if I factor an x out of the first set of brackets, I'm left with 3x minus 5. The second set of brackets is already 3x minus 5, so this is good. So one factor is the set of brackets that is the same. The other factor are the coefficients of those set of brackets, so x minus 1. And it's still equal to 0, so I know that my factors, when they equal 0, that's how I'm going to find my x-intercept. So one of them is 5 over 3, and the other one ends up actually being positive 1. So I can do this with decomposition as well, right? As long as it's factored, I can take each factor, make it equal to 0 to find the actual x-intercept, or 0, or solution. They all mean the same thing, right? So these are the x-intercepts, they are the solutions, or they are the zeros, right? They mean the same thing. All three of those words, well, all three of those terms, I guess, are the same thing. And we can do this also with, if I remember, any special polynomial. So if it's a difference of squares, as long as I can factor it, I can do the same thing. So I've got a polynomial here with two terms, and they don't have any common factors between them. So I'm going to check to see if the first term is a perfect square, which it is, right? X squared is a perfect square. So is 16, and there's a subtraction sign inside. Now if that's the case, well, I can make two factors for myself. The square root of the first term goes in, so the square root of x squared is x. The square root of 16 is 4, and in between them go different signs because this is a difference of squares. And if the signs are different, well, it means my middle term will cancel out if I were to distribute this. So I've got it factored. So now everything's the same. Take a factor, make it 0, solve for x. So here, x is negative 4, or x is positive 4. So there are my two x-intercepts. So a difference of squares case is quite nice because they're very easy to factor them, relatively speaking, compared to the other polynomials. So again, this is a difference of squares, because 4x squared is a perfect square, and so is 9, and there's a subtraction sign. So the square root of the first term is 2x, the square root of 9 is 3, and there's different signs in between. Now it doesn't matter if the plus sign goes first or the minus, it makes no difference. But again, take each factor, set it equal to 0 to solve for x. So one of them is 3 over 2, but the other one, if I take that factor and make it 0, it actually ends up being negative 3 over 2 when you isolate for x. So you can do the exact same thing as long as you can factor it. So again, A and B basically set the stage to do C and D. They are identical. So in order to finish up this video, it's a quick one, because really we're just doing something we've done before, which is factoring, but taking it one little step further. So Pedro solved a quadratic equation by graphing, and he determined that the roots were negative 3 and 4. Determine an equation in factored form that he might have solved. So essentially what Pedro has done has determined that, well, the solutions, or the roots, or the zeros, or the x-intercepts, again, they all mean the same thing. One of them is negative 3, and the other is 4. Now again, to go backwards, well, this is the end part where we've taken everything that we've done so far and gotten to this point, but now we're going to do this in reverse. So I'm going to add 3 to both sides this time to undo that last step. So I know now that x plus 3 is actually equal to 0. So therefore, x plus 3 is a factor. We're just doing this backwards this time. So for the second one, the same rules apply. So now I know that x minus 4 is 0. So therefore, x minus 4 is a factor. And factors are things that, well, if I multiply them together, they give me an original, expression. So I know that if I take this, well, one possible equation could be x plus 3 multiplied with x minus 4. right? This is the factored form of this, which I think I'm actually, yeah, determine in factored form what he might have solved. So it could have been this, and I'm done. Right? If I know what the zeros or solutions happen to be, I can do it in reverse to come up with a factor. So if x plus 3 is a factor, set it equal to 0, solve for x, and you'll find out that you have negative 3. So the same logic applies to the other one. Right? We just did it backwards this time. So that brings us to the end. Underneath is a flow chart, which will help with some of the factoring. How do you know what to do and when? So you can take a read through it. But really, there's this is the part you need, the summary of this. So it tells you where if you're going to solve one of these equations, write them in a specific format and then factor it, set each factor equal to 0 and solve for the unknown. So usually the unknown variable is going to be x, but it could be anything, right? You might have to do decomposition, you might have to deal with the difference of squares, but this really gives you all the steps that you're going to need. So this is a quick one, brings us to the end. As long as you can factor it, you can find the zeros. So again, you'll find all the links to these, all the full answer key, the notes in the description box. So you can try some things out or just print them and follow along. You'll see the next video linked up above right now. And until then, take care of yourselves and we'll see you in the next one. Bye-bye.